So, then we are talking about memory mapping, because in the last 3 classes we talk about 3 memory mapping that can be divided into 3 major classes. Okay. So, one is I said ki direct mapping. Okay. So, if you remember clearly that direct mapping, we said ki main memory address will be divided into 3 parts. One is called the word, another is something called block number or cache line, another was tag. Okay. And then we talk about associative mapping. So, here is something, word is always there. What is word? Word to indicates that, as I said, that main memory as well as the cache memory will be divided into a number of blocks. To identify which word within a block, so we need to have the some bits. So, that is something called the word. Okay. And then which block, so that is the block in the direct mapping, and if you remember in direct mapping we use some modulo function. Okay. And then we have here is word and then block number, okay, word, and then so in case of associative mapping what x, then we have a tag, okay, and then we have a set associative mapping. So, we divide into that is word and then set number and then tag. Okay. So, what I said, we will have a example. Okay. So, let us say we have a scenario such that we have a computer system. So, in computer system we have cache and then we have main memory, we have a block. So, these are the assumption for this example: cache memory, okay, each block, and there are 2 sets in case, okay, and there is an array, let us say A 410 is stored in obviously in main memory. Okay. So, in summary, so we have a cache memory, we have a main memory as you can see, so it is in hex. Okay. So, therefore, 4 into 4, so main memory is 16 bit. Okay. Main memory is 16 bit and each location you can have a word 16 bit word, and it is a word addressable, not byte addressable. Okay. So, each location there will be 16 bit, and starting that array, for array starting location is 7S00. Now, we have a program. So, in last class I wrote that program, again I will write it here, and then if that program gets executed, so what will be the content of the cache memory? Cache memory has 8 blocks. Okay. Each block contain only one word. Okay. So, if you have a multiple word in a block, then only you need to identify each word within a block. So, because you have only one word, so therefore, there is no need to keep extra bit for the word. So, what I wanted to say for many guy, it seems, so let us say this is a block. Okay. So, I have 8 words. So, which word I want to identify? So, I should have a number of bits. So, that is 3 bits. Okay. So, as I said, you use log of 8, you will get 3. Okay. So, now my question is, you have a block and you have only one word. So, definitely if you identify the block, then it is sufficient, no need to identify again within a block that which word, because you have only one word. Okay. So, based on this, we have to, if you go for using direct mapping, how do you divide the main memory address into 3 bits, into 3 fields. Okay. Okay. Main memory, just few minutes before I said that it will have the word, next we will have the block number in the cache, and then we have the tag. Okay. And how many bits there in the main memory? Here we have 16 bit. Okay. So, let us say I need program I did not write, say starting location is 7A 00. So, then if you write in binary, so this will be 0 1 1 1, then it will be 1 0 1 0, 0 0 0 0 and then 0 0 0 0. Okay. So, let us say we have a array that is stored in the column measure. So, at this location, okay. So, this location, we have an array that is A 0 0 and this is the starting location 7A 0 0. Next is 7A 0 1. So, you will have 0 1 1, 1 0 1 0, 0 0 0 0, 0 0 0 1. So, this will be A. Next location will be, it is stored in the column measure. So, next location will be A 0 1, A 0 1. Why? So, array is something like that, this is 0 0, this is 0 1, okay. This is 0 2, this is 0 3 and so on. Next is, so this is 0 1 2 3, this is row 0, this is row 1 and so on. So, it is in column measure. Column measure means what? So, this column it will be stored in column wise. So, therefore, 0 0 next will store in 1 0, not 0 1. So, next will be stored in which element? It will be stored in 1 0 because column, next column is 1 0. So, next is 7A 0 2, this will be 0 1 1 1, 1 0 1 0, 0 0 0 0, 0 0 1 0. Next will be A 2 0, right, column measure. You must have studied in data structure classes, rigorously data structure class was taken, right. Okay. So, next is 7A 0 3, 0 1 1 1, 1 0 1 0, 0 0 1 1. So, this will be A 3 0. Okay. Next 7A 0 4, 0 1 1 1, 1 0 1 0, 0 0 0 0, 0 1 0 0 and next will be A 4 4 0, A 0 1 because next column, right, here, because it is only 4 row, it has only 4 rows. Okay. So, do not think that I will continue the till the everything, then class will be over. Okay. So, then how many elements you have? Can you tell the what will be the last one? 7A. So, here we have 40 elements, right. So, what will be the last address? Last element, that is 49 starting from 0, started from 0th location. So, we want to store 40 elements. So, what will be the last address? 7A 39, but it is in hexadecimal. So, 27, yeah, someone said, right. So, this will be 0 1 1 1. So, offline class is good actually, at least one guy responded. Okay. So, 1 0 1 0, 0 0 1 0 and then 0 1 1 1. So, this will be the last, sorry, unfortunately, yeah. So, this will be A 3 9. Okay. So, now task is that we have 3 techniques as I said. So, first one is direct mapping. So, in case of the direct mapping, how do you divide this 16-bit address? Let us say first block here. So, how do you divide this 16-bit address into 3 fields? First is the word, right. As I said that there is only a single word. So, there is no need for keeping any bits for identifying word within a block, because block consists only one word. Next I said ki if you go back here, So, block number. Okay. So, what is block number here? So, block number or cache line, block number in cache memory. Okay. So, then how many blocks are there in the cache? 8. So, you need 3 bits. So, these 3 bits basically will identify the cache line and rest will be tag. This will be for direct mapping. So, what will be the for associative mapping? What will be the how many bits for associative mapping? How many bits for associative mapping? 16, right. So, entire 16 bit will be for tag in case of the associative mapping, and rest is set associative mapping, set associative mapping. So, then how many bits for the word? Word is nil, and then you have to identify the set, which set. Okay. So, which set means how many sets are there? 2 sets. So, you need 1 bit. So, therefore, only 1 bit. So, this is, let us say here this will be set number and rest will be tag. Done. Okay. But we have to again come back whenever required this figure. Okay. Now, I will write that code. So, what was the target? So, you have to show the content of the cache whenever a program is getting executed. So, now I will write the program. Okay. So, here program is nothing but we have the array, we have to just sum the number, we have to find the average of the first row, and again we have to basically we have to normalize each value in the each value in array element. Okay. So, that is the program. Okay. So, first we have to do it like obviously I have integer a for 10. Okay. Okay. So, for j equal to 0, j less than 10, j plus plus. Then what we do it, sum equal to sum plus a 0 j. Okay. And then you find the average, assume that each instructions are there in the cache memory, that we are not. So, we have 2 parts, right, one is instruction, another is the data, right. So, we assume the instruction is available in the cache. Okay. So, this is we are talking about mostly the data cache. Okay. So, this is sum divided by 10. Okay. And then we have another loop for this is I, this will be I 9, I greater than equal to 0, I minus minus, and then what we do it, so a 0 I equal to a 0 I divided by average. Okay. So, simple program. Now, what we have to do, we have to show the cache content. Okay. So, this is actually MS what is called is whiteboard is good, but we will see next day onwards. So, now you have to remember this part, cache block, cache has 8 blocks, each block contain only one word. Okay. And this is the how we stored the data, like 7A00 location we started, and then for direct mapping we have the bits for associative mapping and for set associative mapping. Now, if we use the direct mapping, what will be the content? If we use the set associative mapping, what will be the content of the cache memory while executing the program? Okay. So, and then this is the program, and now we have to show what is the content of cache. Okay. So, here we go. So, now we have offline exam. So, we can easily ask this question. Okay. So, at least some student will be attentive. Okay. So, here block is 0, let us say this is the block number. Okay. So, here is block number, block is 1, block 2, block 3 or cache line 3, 4, 5, 6, 7, oh. So, how many blocks? We have 8 blocks, right? So, it is not required. Okay. Now, what we do it here, it is not clear actually what I am going to do to you. Okay. So, here, so let us say this is the block 0, 1, 2, 3, 4, 5, 6. Okay. This is the block number. Now, first you assume that first code here. Okay. It is sequential machine. Okay. So, first it will be executed this part and next it will be executed this part. So, we will be concentrating on loop. So, first what is there? So, say you assume that other variables is available in the cache. Okay. Only we will be talking about this part. So, what is that? A00, right? A00 was stored in the main memory, that has to be brought to the cache memory. And question is that if you use the direct mapping, where it will be stored in the cache, that means which block in the cache memory it should be stored if you use the direct mapping. Question is so simple. We have to bring the data, that is data is A00 first. Okay, data is A00, where it is there in the main memory, you know that it is there in the location 7A00 and we are using direct mapping. So, therefore, it should be placed in the cache memory, but in which block in the cache memory. Okay. So, we divided the entire main memory address into 3 fields, that is one is actually nil, that is word is nil, and then we divided into block number and cache block number and tag. So, then you go here. So, what is the block number here? This 3 bits, least 3 bits decides the block number. So, it is 00. So, therefore, it will be stored in the cache block 0. So, it will be stored in the cache block 0. What it will store? A00. Next, you go to the program here, which data? A01. Where it is stored in A01? A01 was stored here, not sequentially here. Okay. A01, because it was stored in the column order, but I need to access in the row wise. So, A01 was stored in 100, therefore, block number is actually 4. So, therefore, it should be stored in the block number 4. So, where is block number? Here, A01. Okay. So, what is the value of j? What is j? J is that looping, right? What is the value of j? J is 0, 1, right? After j equal to 1, after second pass of the first loop, the content of the cache is something like that, if you use direct mapping. Okay? No doubt. Now, you move to the program here. So, what is this? Next is 0, 2. 0, 2, where it will be stored? Ideally, I should have written the entire memory part, right? Then only it would be easy to answer. But from intuition, you see 0, 0 was stored in the 0, 0 location. Next 0, 1 is storing 4th. Next, what it will store? It will be 8. Next, it will be stored in 12. Next, it will be stored in 16 and so on. So, therefore, where it will stored? 100, next location will be 1000. So, next location will be 1000. So, you take 3 bits. So, where it will be stored? Again block 0, because we are using direct mapping. So, therefore, what will happen? Here 2 data cannot be stored in the same place. So, therefore, it should be replaced and it should be written here A02, right. We are using direct mapping. Another thing I forgot to mention, and we also talk in the last class ki there is something called page replacement policy, page replacement algorithm. What happened whenever cache is full, but in order to keep space for the incoming page from the second memory or incoming block from the not second memory, incoming block from the main memory, then we have to replace some of the block in the cache memory. So, that is something called block replacement policy. I said in the last class, again I state here ki if we have a cache full, then again there is need for bringing the data or block from the main memory to the cache memory. So, in that case you have to replace any one of the block in the cache memory. Okay. So, that strategy, which block should be replaced? If it is entirely full, then who should leave? So, we have a different strategy. Okay. So, one strategy I said in the last class is something called LRU, least recently used. The block which has not been referred for longest period of time should be replaced, and it should a new page will come in that particular position. What is the logic? Its logic is something that when you start programming, maybe some portion some of the block have been used heavily, but after then there is no need for those variable. Okay. So, therefore, those variable we may replace those variable from the cache. So, that is the logic. This is again locality of reference. Okay. So, it may not be that much very useful to get a good score whatever you studied in class 1. Okay. Long back whatever has been used, it may not be those much useful. So, that is why in computer system also it is better to replace those page and bring the new page. So, bring new knowledge and replace the old one. Okay. It is something not exactly the same way, it is like a what is called is just a not exact analogy I made it. So, it is like that whatever you used earlier, it may not be required to be used. That is why you use that space, you bring the new thing into that space. Okay. So, that is the idea. So, that is same way ki that is something called LRU page replacement policy. So, here also will be used LRU page replacement policy, but unfortunately in case of the direct mapping, because it is space is fixed, whatever it needs to be mapped, you need to map there. So, therefore, in case of the direct mapping, LRU page replacement policy has no role. But if you use the set and associative mapping, so there we will see the LRU page replacement has a role to identify that which page we should replace if the cache is full. Okay. So, having said that, now what you do it? So, again you identify j equal to what was the value 1, now j equal to let us say 3. So, what will be the content of the cache? So, A02 and A03. So, again j equal to 5, again it will be replaced here A04, A05. Similarly, j equal to 7, again you have to replace this one, again the same block. Okay. We are replacing in the same block. So, what we say ki how many times the desired block is available in the cache. So, that is something called cache hit. Whenever it is searching for particular block, if the block is available in the cache, that is something called cache hit. Okay. Okay. We will tell this one in details, and if it is not available. So, first data that system required ki A00, it was not there in the cache memory. So, therefore, that is something called miss. Okay. Similarly, here is every time actually there is miss, there is no hit in case of the direct mapping, and you observe carefully that there are space in the cache memory, but it is not getting used because we are using the direct mapping. That is the inherent drawback of the direct mapping scheme, we cannot do anything. So, then j what will there j06, A07. Okay. So, j, so let us say 9. So, you will have A08, A09. Then first loop is over. Now you go to the second loop. Okay. So what is that here? Second loop started with I equal to 9, and which data you need? You need to access this data A09. First it will search in the cache whether it is available. If it is available, so that is something called cache hit. Okay. So you go to the here 09, it is available. So no need to bring the data again from main memory. So that is something called hit happened. Okay. So there is a hit. Next is 9, then it will decrement the value I, so it will be 8, again there is hit. So twice we got the hit. Okay. So then what is the value of I? I is 8, and then we got hit 2. So you remember that we had 2 hit. Next I value is 8, so I value is 7. So data is available here, data is not available. Okay. So then you have to bring the data from main memory to cache memory, right. So where do we place? We are using direct mapping. Where do you place? In which block in the cache? From 0 to 7. Which location we should place? Which block you should place? So then you have to go to the which location in the main memory. Okay. And then you have to take the 3 significant bit, 3 least significant bit, and then that will decide that which block it is. So if you carefully see that we already said here 07 should be in the block 4. Okay. So therefore again we should write it here 07. Next is 6. So 6 will be A06. So and go on. Okay. So we keep on going at the end. So every time it will be the new data, because we can store only the two words in 2 blocks, because other you cannot use because of the direct mapping problem. So therefore it is asked that how many hits you get out of how many times you tried to access. That is something called hit ratio. So hit was 2, and how many times you access? 20, because first loop was 10 times, second loop was 10 times. So this is the hit ratio. Okay. Now question is, if you go for the associative mapping, what will be the content of the cache? Okay. So what is the program here? Program is remain same. So first let us say initially all are 0 here, initially 0. So nothing is there, because we have a different memory mapping scheme, and but we have to remember one thing, we are using LRU page replacement policy. And then what is say associative mapping? In case of the associative mapping, we can keep the data any location, means any block, okay, and we can keep anywhere, because it will come as a block, because each block is having only one word. So we can keep in any block. Okay. So first content was A00. So where do you keep? You can keep 0 to 7, you can keep anywhere. So first is A00, next is A01. If you go to the memory mapping scheme here, what was that case? So in case of this was the entirely tag, so there is no block number here. You can keep anywhere, right? So no block number. So therefore next we will keep, let us say anywhere we can keep A01, next we can keep A02, A03, A04, A05, A06, A07, and then what is the value of J? J is 7. Okay. Now J value is 8. So you can keep anywhere, but cache is full. So then you have to identify any one of the block which should be replaced. Okay. So now we have a policy, that is LRU policy, least recently used. So we will keep only, we will replace those pages, those are the victim page which has not been used for longest period of time. So which one was referred at the very beginning? That A00. So therefore it will be replaced A00, not A07. Okay. So, therefore, if j equal to 8, then this will be replaced. Okay. So, this will be a 0 8 and then all other remain same, I am not writing here. Okay, j equal to 8. Now, you make j equal to 9, j equal to 9 is also not there, and then memory is full because this is there and then all those things are there, I am not writing. You ideally actually a 01, a 02, a 03, I am running a 04, a 05, a 06, a 07. Okay. So, j equal to 8. Now, j equal to 9, there is no j, that particular word is not there in any one of the block. So, therefore, what you have to do? You have to replace any one of the block. So, which block I should replace? 01, because it came long before. You cannot replace 08, just it came. It may be used, right. So, therefore, you write a 09, a 08, a 02, a 03, a 04, 05, 06, 07. Okay. So, then first loop is over. Okay. So, now you talk about loop I equal to 9. I equal to 9 means actually a what, which data we want, a 0 9, whether that is there in the cache, whether that data is there in the cache, it is there. So, that is hit. Okay. So, count. So, 09 is there, next is 08, that is also is there. So, 09 is there, 08 is there, 07 is there, 06 there, 05 there, 04, 03, 02. So, all are hit. So, what is the value of I? So, I value is 2. How many hits we get? 8, because you cannot get more than that, because size is 8 only. So, we will get 8 hit. Next, I equal to 2, that is also hit. I equal to 1, even I equal to 1 means a 0 1. So, that data, that block is not there, as you can see here. So, therefore, what you have to do? You have to replace any one of the blocks. So, which block you should replace? Which came longest, earliest one? 02, 02 just now came, 09 or 08, I think it was 08. So, there was 07, then we bring 08 and then 09. Okay. So, therefore, which block should be replaced? Okay, just a minute, I should correct myself one thing. It is not only that which was the oldest one, it is actually that which has not been referred, which has not been referred. Okay. So, it was 09 was referred, even though it came long before, again 09 was referred, then 08, then 07, 06, 05, 04, 03, 02, which was referred just now, that is 02. Okay. So, then which was longest, earliest it was used, so 09. So, then replaced should be 08 or 09, 09. So, you replace 09. So, it should be a 01. Okay. So, then again you replace the oldest one, that is not only oldest, sorry, it is wrong statement, we should replace the oldest one. We will replace which has not been used or has not been referred for long time. We identify and then we replace it. Okay. So, next is a 0 0 and then rest will be the same. So, you count how many times you had hit and then total number of referred. So, total number of referred remains same, that is 20 and hit is 8. So, then in case it will be hit ratio will be 8 by 20. Okay. So, next is set associative mapping. So, in case of the set associative mapping, we will see some interesting thing. So, we have two sets. So, therefore, this 4 block will form a set 0 and these 4 block will set 1. Okay. So, what will be the content here? So, again you consider the first loop is A00, where it was A00? A00 was location here. So, we use set associative mapping. So, therefore, which set it will go? Only least significant bit, it is set 0. Okay. So, therefore, you place in set 0. Okay. Set 0 is this one. So, set 0 you have 4 blocks. Okay. So, value of j is 0. So, you can place anywhere, because you know that set associative mapping, first you identify set 0 and you keep any block under set 0. So, you can keep A 0 0. Okay. Next is 0 1. 0 1, where it will be mapped in set 0 or 1? Why 1? 0 1, where it is in the main memory? 0 1 is 4, 0 4 8, all where the all are even number, least significant bit is 0. So, therefore, everything will be mapped to set 0. So, at a time only 4 it can store, because in a set 0 there are 4 blocks. So, therefore, what will happen? So, sorry, here A01, next it will be 01, it will be 02, because 4, 8, 12, 16 all are even number and least significant bit is 0. So, A03. Now, whenever you want to bring 04, 04 where it will be placed, again set 0, but there is no space in set 0. So, therefore, you have to replace. Which one will be replaced? You just now you use 03, before that 02, before that 01. So, therefore, you replace A00. So, here A04 and so on. So, you will go with complete with J, and then again you come with I, and then you find how many times it hit and total number of referred. Total number of referred 2 loops, so 20. Okay.